The wind catches the feathers first, lifting two huge eagle wings off the back of an emperor penguin standing on the ice. For a second, it looks as if this animal is about to do the one thing penguins are famous for not doing. But would those wings actually be a gift, or would they ruin the penguin's real superpower? This picture is fictional, but the biology test we are about to run is real. Our penguin keeps its heavy diving shape, its thick feathers, and its icy home. Only one thing changes. Its short, stiff flippers are replaced by broad, jointed wings covered in long flight feathers. To see if this animal survives, we have to look at something you can feel with your own hands. Push your hand through the air, and it slides easily. Push that same hand through a swimming pool, and your arm has to work. Water is hundreds of times denser than air. This diagram compares a broad eagle wing and a compact penguin flipper. The eagle wing is wide because air is thin, requiring a large moving surface to catch the flow and create lift. The penguin flipper is narrow, stiff, and paddle-like because it has to push against thick water. Both of these limbs are wings, perfectly shaped for their own worlds. Taking a wide, flexible surface made for the sky and forcing it into the dense ocean creates immediate problems. We start the test on land. Real penguin colonies are incredibly crowded. Thousands of birds waddle close together, keeping small flippers tucked safely by their sides. Give one of these birds eagle wings, and it suddenly needs a lot of room. A single turn bumps into neighbors. Lowering the body to rest drags long feathers across abrasive ice. A sudden gust of wind catches those huge panels and knocks the heavy bird off balance. The tempting idea is that these wings let the penguin fly away from crowding. But an emperor penguin is built like a dense torpedo, with heavy bones and short legs. It cannot sprint into a headwind like an albatross to take off. Lifting that heavy, sinking shape into the air demands massive chest muscles and burns a huge amount of calories. A penguin already needs its fuel to stay warm, molt, and survive long fasts on the ice. The new wings might allow an awkward glide from a snowy ridge in a strong gale. On the surface, it trades the ability to walk easily for a few clumsy seconds in the air. The real trouble starts at the water's edge. A normal penguin drops into the sea like a sealed dart, but our hybrid jumps and hits the surface with a violent slap. The broad wings catch the liquid and pull the bird to a halt before the dive even begins. In the sky, the flexibility of long feathers gives an eagle precise steering. Below the ice, the water grabs every edge. The feathers bend and twist against the flow, turning the wings into two massive, uncontrollable breaks. Real flippers solve this by remaining perfectly stiff. They push the heavy water with short, compact strokes, generating speed without folding under pressure. The trailing drag of eagle wings ruins agility. One wing catches more water than the other, pulling the heavy body off balance and widening the bird's turning circle. Fast, erratic prey like squid and krill easily slip away. As the penguin dives deeper into the freezing dark, the pressure rises. Fighting the drag of loose feathers burns precious oxygen, severely cutting down the time the bird can spend hunting. By bolting on parts made for the sky, the bird loses its frictionless underwater speed. Then the cold seeps in. Real penguins use a rounded, compact shape to trap warmth. Adding giant wings increases the body's surface area, exposing more heat to the freezing water and biting winds. That sluggish movement invites danger. The Southern Ocean is patrolled by watchful predators like leopard seals and orcas. A penguin survives these encounters through explosive speed and split-second turning. With long feathers dragging behind, our hybrid becomes a slow, easily readable target in an environment that heavily penalizes mistakes. The real cost of failing to hunt and outswim danger is waiting back on the ice. A parent that spends too much energy fighting drag catches fewer fish, returning to the colony with an empty stomach and a hungry chick. Those long feathers even make raising that chick harder. Wide, unwieldy wings keep parents from pressing close together into tight, warm huddles, leaving the young exposed to vicious storms. This design fails the individual bird, and it guarantees the chicks will not survive the winter. The survival scorecard tally is grim. The tiny bonus to air movement is crushed by severe penalties to swimming, hunting, and warmth. penguins did not accidentally misplace the ability to fly. They traded long feathers for stiff paddles to conquer a much thicker world. The eagle-winged penguin mostly fails in the wild because it trades the tools it needs to eat and stay warm for an adaptation it can barely use. Below the surface, a real penguin sweeps its small flippers once and slides through the water with effortless grace. The best wing isn't the biggest one, it is the one perfectly shaped for the world you actually live in.